This is a demonstration of a simple conveyor system used for placing either pellet A or pellet B into a box as it moves along a conveyor belt. The first step along is as the box moves forward, this RFID reader would detect a small embedded tag or sticker that would tell whether or not the box was slated to have pellet A or pellet B put inside of it. In the event that no tag is detected, the two wires on this Metro Grand Central board, which is what is currently reading the input off of the RFID, would send two high signals. While two high signals are sent over to this board, which is currently controlling the servo-based pellet dropping systems and the motor, which in this case is right now symbolized by this blue LED, it would disable the motor, setting this to low, and would stop the conveyor, basically waiting until a new box was placed with orders. This is handled within the void loop of this board, so it's always waiting for the next set of input. And when this was built into an actual conveyor model, the motor was hooked up to a 12-volt power source, and this was used to control a MOSFET in order to get that motor going and stopping. Now, in this case, I recently placed a tag on it that has told the system that option A is what is needed. Now, when option A is detected, we get a high off of the green wire and a low off of the yellow wire. That goes over to this system. Now, in the void loop, there is a if statement that if that is what is detected, what it will do is it will attach an interrupt to this switch and detach the interrupt to this switch, both of which were originally attached in the setup of the Arduino function. Now, and it will then activate the motor, which will get it rolling. Now, as the package moved along the conveyor belt, it would eventually bump into one of these limit switches that were on the side so it could still keep going past. Now, right now, because it is aware that it wants option A, this B switch, if ever clicked, does not currently do anything because, once again, the interrupt has been removed from it. However, option A's switch here does currently have an interrupt and an attached function which operates the pellet dropping system. Now, when it gets hit, the first thing that'll happen is this light here will actually turn off because in the actual conveyor belt, we would shut off the motor to make sure that the box stays still while that goes to drop the pellet inside of it. This is done as a simple setting the control wire for the motor to low, running through the loop that involves the movement of the servo, and then setting it back to high again. This is done instead of using any sort of delays because delays don't seem to work inside of the interrupt functions. So to demo this, box A has been detected. It is currently moving along due to the conveyor being propelled forward. And then as it hits the switch, this set of rotating discs would line up so the pellet would then fall through the bottom. It actually then resets to a base position where there is a hopper plate above that could hold more additional pellets in order to continue this process over time. I've taken the top off of it to better show it in its current state since the conveyor broke. Now, just to explain what would happen in the other option is if option B had been sent here, this board, these two wires here, the green and yellow one, would have been the opposite, and then this switch would have had its interrupt detached from it, and this one would have had it attached. To basically show a bit of that in the code, all of these were set up, including the servo code, pin inputs and such, but originally an interrupt with two different ISR functions were attached to both switches in the setup just to make sure that there's no possibility of error. And then based on the option indicator pins, as I named them, either being high and high, just turning the motor off, or high and low and such, then setting which ones to attach and detach the interrupts to, and then reactivating the motor, allowing the system to function properly for whichever one has been selected to be put in the box. This does allow the system to basically run indefinitely. Now, the RFID reader originally was placed very close to where these switches were. In fact, it was just in front of it, because when placed on there, if you add a box back to back, it would cause an issue to where it could possibly switch it. For instance, if a box A was placed on first and it moved forward, but box B was detected before the A switch was hit, it would then move on and get a B pellet. However, by placing these very close to each other and in sequential order, this allows for a very small gap to be used in order to maintain the proper level of accuracy.